All right, let's talk about graphing lines. We've already talked a little bit about graphing previously, and the best way to graph, kind of the most basic way to graph, is just making a table of values. However, sometimes a table can be very time consuming. It takes a long time to find a lot of points. If you have an equation such as the one right here, 3.5x plus 7y equals 14, again, we first have to solve for y, and then we have to make that table, pick some values for x, plug them in. It seems like there's a lot of work going on there. And again, we don't really know a good number of points that we should have. Another way to kind of graph, and a great way to graph, especially when we're in what we're called standard form. Again, an equation such as the one on the bottom there, but notice that x and y are on both on the left side, and we have a constant of some sort. So down here, that would be the 14, right? There's no variable there. Some sort of constant number on the right side, but we've got a couple of coefficients, a and b, right now, 3.5 and 7, and a constant on the other side, 14. That's that standard form, right? X plus y equals constant. And a great way to graph, as I was saying, a standard form equation is to use the x and y intercepts. Again, 2 points makes a line. So we don't need 100 points to make a linear equation. If I know this is x to the first and y to the first, I know it's going to be a linear equation, a linear graph. So it's going to be a straight line of some sort. In that case, if I get 2 solid points, I can make a nice straight line and we can judge where our graph goes. Now, that won't necessarily be the most accurate graph all over the place. It depends on us drawing as straight a line as possible. But if we're just looking for a general idea of what's going on, it's a great way to approach it. So what we want to think about are the 2 easiest points possibly to find would be the x-intercept and the y-intercept. An x-intercept is, again, a point on the x-axis, which means that y equals 0. We haven't traveled up or down, right, from the axis at all. So if y equals 0, right, what I'm going to do is take my equation down here at the bottom, and I'm going to plug 0 in for y. All I have to do is then follow the steps. The nice part about plugging in 0, what makes it so simple, is that, again, 7 times 0 is 0, and 3.5x plus 0 is really just 3.5x. So a simple solve, if we're multiplying by 3.5 right now, 3.5 times x divided by 3.5. Again, we'll divide both sides. Basically comes down to 14 divided by 3.5, which is simply 4. So we would say that, again, our x-intercept, when y equals 0, would have a coordinate of 4, 0. So I could go over to my graph, assuming I'm counting by ones here. I'm going to go ahead and go 4 units to the right, and I'm going to plot the point 4, 0. We could do the same thing over here at the left. If x were equal to 0, again, we call that a y-intercept. Any point on the y-axis, we haven't traveled left or right, is called a y-intercept. It's where we're intercepting the y-axis. But again, every y-intercept has a value of x equals 0. So we'll just take in our equation here. We're going to take out the x, and we're going to plug in x equals 0. Again, 3.5 times 0 basically turns into 0, and 0 plus 7y is really just 7y. Again, so 7y equals 14, right? That first term disappeared. And now if I divide by 7 on both sides, right? 7 times y will cancel by dividing by 7. That leaves the y where it is. And 14 divided by 7 is 2. So again, our y-intercept, when x was 0, our y-intercept will be 0, 2. So I can, again, assuming I'm counting by ones, I'm going to plot 1, 2. I'm going to plot a point right there. And now it's our job to draw as straight a line as possible. Again, we could get out a ruler and try to do that, or we can judge the points a little bit. Notice from one point to the next, if I go from the y-intercept down 2 units, right 4 units, right, I got a point. Well, that sounds like a good pattern to me. So why not go up 2 units and keep going left 4 points or 4 units? That point should fall in a straight line with the others. And same thing, if I go down 2 right 4, well, kind of thinking about proportions, why can't I go down 1 right 2? Doesn't that point seem to fall in the same line? Down 1 right 2, down 1 right 2. Or if I can go up 1 left 2, up 1 left 2, up 1 left 2. All of those points fall in a nice straight line. And again, we can draw ourselves a nice straight line. The more points we have, the easier that is to do. And don't forget your arrows. So again, with a domain of all real numbers, I can plug any x that I want in, or a range of all real numbers of all the y's that I want. We want to connect those dots because all the points between the points we found, especially those two easiest points, right, the intercepts, all the points on the line would make the equation true. Again, that's a great way to graph. So let's try one more example here real quick. We've got an equation up top. Notice it's in standard form. Again, x plus y equals constant. So this is a great chance for us to go ahead and find our intercepts. So let's use our intercepts to graph. Let's say if x were 0, well, 2 times 0 plus 5y equals negative 10. And again, 2 times 0 is just 0. 0 plus 5y can kind of cancel away. So 5y, 0 plus 5y, sorry, that 0 can disappear. Because 0 added on to anything really doesn't matter. And if I divide by 5 on both sides, we'll find out that y equals negative 2. So we can plot a point at 0, negative 2. Again, assuming I'm counting by ones, I'm just going to label these 5s out here, counting by ones on my graph. Let's do the same thing as far as the other number here. So we're going to find x when y is 0. Well, 2x, and again, plus 5y, but again, if y is going to be 0, I can kind of ignore that term, can't I? So basically 2x equals negative 10 because y was 0. Divide by 2, divide by 2. Since I'm going sideways, I'll use an arrow here. X, right, 2 over 2 disappears, is equal to negative 5. So we'll plot a point at negative 5, 0. And then all we have to do, very simply, is connect those dots. But again, the more points we have, the easier that might be. So notice from the blue dot to the red dot, I would go down 2, right 5. Well, why not go down another 2, right another 5, and end up and graphing our line right about there. Again, it's a quick and simple way. 2 points makes a line. The two intercepts, the x-intercept and the y-intercept, are really great things to find. Now, the one tricky part, don't forget, it's an x-intercept because y was 0. That's going to put it on the x-axis. It's a y-intercept, right? Or what we often call the y-int, right? Y-intercept, because x was 0. Now, where can we kind of apply this? Well, sometimes in the real life, some problems really correspond to standard form very well, and this could really help us out. So notice on the screen, we've got a problem about the student council selling tickets. They need to sell $2,000 worth of tickets. They obviously have a budget. They're trying to make sure they've got $2,000 to do whatever, expense that they have. The cost of a student ticket is $5. The cost of an adult ticket is $10. Well, what if we consider the fact that if we want to make a graph out of this, well, we can kind of think ahead. I'm going to jump down to the bottom a little bit, write an expression relating the tickets sold to the goal. Well, if we call the student tickets X and the adult tickets Y, basically there's $5 per student ticket that we're going to make, and we're going to make $10 per adult ticket, only we're going to add all that money up, and we need to make, as we said, a goal of $2,000. So if we can find a bunch of XY coordinates to make that a true statement, we could make a graph. Well, if we want a general idea of what that's going to look like, why don't we consider those questions in the middle? If they don't sell any adult tickets, basically saying that y equals 0. It sounds like an x-intercept to me. How many student tickets do they need to sell? Well, without any y tickets, without any adult tickets, $5 per student ticket would need to make up the entire $2,000. So if we divide by 5, we would quickly find out that we need to sell 400 tickets, right? 400 youth tickets, student tickets on there. Same thing goes on the next question. What if we didn't have any student tickets sold? Well, there's $10 per adult ticket And again, we need to make $2,000. So let's divide by 10. And you would find out that y equals 200. Now that also saves me from accidentally counting by the wrong thing on my graph, right? Because if I take a look at my graph, I could have counted by ones, but wait a minute, I want to get to 400 in the x's and 200 in the y's. I'm going to have to count by something much larger. Why don't we count by 50s for the x's? So that makes this 100. Skip a point, so this would be 200. 250 is 300. 350 is 400 right here. And that means I can plot that x-intercept. And the same thing goes, well, we need to get to 200. Well, why not count by 50s again? How about? We'll just be consistent. That makes this 100, 150 is 200. And again, you could continue to label if you want to, but remember, I'm plotting the point at y equals 200, right? 0, 200 would have been that y-intercept. Now that gives me a pretty good idea of what I'm looking at. If I can draw a straight enough line to connect my dots, it also gives me an idea of where else I could find points. What if somebody asked, well, what if we have a combination? Well, I could quickly look at this and say, well, for 100, right, 100 student tickets, we would need to be at about 150, right? 150 adult tickets, right? Because that's a point that falls on the line. And I could find other points, anywhere in between those. So that's a very helpful part of that graph. Now, state the domain and range. Notice that this is a real world problem because I can't sell negative amounts of tickets. I don't really need anything over in quadrant 2. Notice I didn't even graph a quadrant 2 or down in quadrant 4 or quadrants 3. I only want the points on this line, right? I only want the points on this line. And this line only exists from left to right. Thinking x values are the domain. It only exists from 0 up to 400. So my domain, right, I'm going to say is 0 less than or equal to x, the actual number of tickets, right? I can sell 0 tickets, 0 student tickets, or I can sell more than that. But I can't really sell more than 400 because I would exceed that $2,000 goal, right? Once I sell 400, I would be just fine. I would be done. In that same way, let's picture the range, right, from top to bottom. And we're going to say that we're going to go from 0 is less than or equal to y is less than or equal to, notice the y values never go above 200, right? So there we go. They never go above 200. I hope that helps you thinking about where you could use standard form, where graphing by intercepts would be a good idea. Again, that's really the major idea of this section. Can you find the y-intercept and the x-intercept so that you can plot those 2 points and very quick and simple, draw a line. If you have any questions, talk to your teacher. Otherwise, have a great day.